Okay, time to look at some extended response questions. This is the 2013 exam. I'm going to walk you through each of the 4 or 5 questions. I forget how many. It'll probably take me a little bit longer than some of the other videos, so feel free to fast forward to the question that you found difficult. I'll be using the ClassPad 2. I'll try to show you some cool stuff on there that you might not have seen before, and hopefully you get something out of it. So moving on, question 1, which is about Trig the gardener. Trig because it's a trig function. Do you get it? Very good. So he's a gardener and he's working in a greenhouse, and the temperature in the greenhouse is given by this function here. So I reckon first thing you should always do, type in the function. So 25 plus 2 cos pi t on 8. So let's use x. So we've got our function in there, so we can play around with it. Now, we won't define the function. I think we'll save that for a question a bit later on. I don't think we really need to for this problem because we only use it a couple of times. So we want to find the maximum temperature and when it occurs. If you know your cos functions, you should be able to tell that that's going to go between 27 and 23. So the maximum temp's 27. What you could do is you can use a function on the calculator here called fmin or fmax, and we'll drag this down here, and that'll actually tell you that the maximum is at 27. And what you could do is we could go given that, and then we could say between 0 and 24. And the calculator will actually give us the full answer. So I'll tell you that the maximum is 27 and it happens when x is 0 or 16. So that gives me my first answer. The percentages here will be the percentage of people that got full marks on each question, and make sure you check out the examiner's report for some more tips. Alright, moving on. The period of the function 2 pi on pi and 8 is 16. I'm not going to explain that any further. Now the smallest value of t for which t is equal to 26, so we would set the function equal to 26. So maybe we'll drag this down here, set it equal to 26 and solve. And again we can put some parameters on that, make it tell us between 0 and 24. Don't forget to give in that sign. And that'll tell me 8 on 3, 40 on 3, 56 on 3. So the smallest one obviously is 8 on 3. So there's my answer. 2 marks there, so make sure you show it working. I wouldn't just have 8 on 3. So maybe say that you're setting the function equal to 26 or something along those lines. Moving on to part D. For how many hours during the 24-hour time interval is t greater than or equal to 26? So we've already found that it's equal to 26. When t is 8 on 3, 40 on 3, or 56 on 3. So it's just a matter of, well, is it between these or is it outside of these? We're not really sure. So you could just sketch the graph quickly. I think I already did this earlier, so the window is probably about right. And there it is there. So we could have just changed our window. We know we're going to go from 0 to 24 and y is going to go from around 0 to 30. So you should be able to see just by looking at that 8 on 3 is going to be around about there. So it's going to be greater than 26 between 0 and 8 on 3 and 40 on 3 to 56 on 3. So the amount of hours is 8 on 3 plus 56 on 3 minus 40 on 3, which simplifies to 8. Alright, still on question 1. Now Trig's designing a garden, and we're no longer interested in 2 cos x pi on 8 anymore. We're now looking at the function y equals sine x between 0 and 2 pi. So the garden beds are here, these shaded regions. We're also given a point P, the coordinates of that point, and we're told that the line segment PC is actually part of the tangent at that point P. So that will be helpful. So first of all, we want to find dy dx when x equals 2 pi on 3. Pretty straightforward. Differentiate sine x, you get cos x, and sub in 2 pi on 3, you get negative 1/2. Okay, now show that the value of C is root 3 plus 2 pi on 3. So this is a show that question. We're going to do a little bit of work, which is annoying because it's only worth 1 mark, but easiest way to do this, use the equation of a tangent. So the equation of a straight line, which is y minus y1 equals m bracket x minus x1. So there's x1, there's y1, and the gradient was negative a half. Sub all of that into the gradient to the formula, and that gives you that. Now we want to find C, which is the x-intercept of that tangent. So we'll find an x-intercept of a straight line. You'll let y equals 0, and if we rearrange this and solve, we get what we're looking for, root 3 plus 2 pi on 3. Alright, it starts to get a bit trickier now. In further planning for the garden, Trig uses a transformation of the plane defined as a dilation of factor k from the x-axis and a dilation of m from the y-axis. So if x prime, p prime, and c prime are the image of the points x, p, and c, find the values of k and m if that distance is 10 and that distance is 30. Okay, so have a look at the segment xp to start with. xp, the distance between x and p at the moment is a root 3 on 2. Now if we dilate all of these points by a factor of, from the x-axis of a factor of k, then that distance there will no longer be root 3 on 2, it'll be root 3 on 2 multiplied by k. So x prime p prime is k root 3 on 2. So therefore 10, because we're told that that distance is 10, 10 is equal to k root 3 on 2, so k is 20 on root 3. We do a similar kind of thing with xc. Now the distance between x and c at the moment, c we found out was the root 3 plus 2 pi on 3, so the distance between 2 pi on 3 and root 3 plus 2 pi on 3 is root 3. So that length there is root 3, and then if we are dilating by a factor of m, then the distance between x prime and c prime will be m times root 3, and we know that it's 30, so solve for m, you get 30 on root 3. Okay, which gives you the answer. Now I've actually, reason the answers are different there is I've rationalized the denominator, so 20 on root 3. If you rationalize the denominator, you get 20 root 3 on 3. Now whether or not you have to rationalize the denominator, I don't know the answer to that, but I did notice in the examiner's report that they did, so it might be a good idea if you want to ensure you get the 2 marks. Okay, so moving on, find the coordinates of the point P dash, where you just got to multiply the x coordinate by m and the y coordinate by k, which gives you 2 pi on 3 times 10 root 3 and so on, and they're pretty easy to simplify to 20 root 3 pi on 2, and that just works out to be 10. Use your calculator to help you if you need to. Remember, we need an exact value here. Okay, I think that's question 1 done. So moving on. Question 2, we have a international company that own a lot of gyms. This is already sounding like probability. And at every one of the gyms, each member agrees to have his fitness assessed by undertaking a set of exercises called S. I'm not going to read out this whole thing. Basically, if you can complete S in less than 3 minutes, you're fit. So at the gym, it's been found that the probability someone will be fit is 5 on 8, which is independent of anybody else. And in 1 week, 20 members attempt it. So what's probably at least 10, so we're talking binomial here. So I've actually written, I'm going to let the number of fit competitors equal x. I'm not sure whether you have to write that, but you definitely do have to write this, that x is distributed binomially, where n is 20 and p is 5 on 8. So the probability x is greater than or equal to 10. Get your calculator out, go into discrete binomial CDF, and our lower will be 10, our upper will be 20, our number of trials will be 20, and our probability of success is 5 on 8. And that will give me the correct answer. Hopefully, yep, 0.9153. Remember, we want 4 decimal places. So a lot of people got that right. Moving on, so given that at least 10 complete S in less than 3 minutes, what's the probability that more than 15 complete it? So conditional probability, so probability X is, I don't need to define X again, I've already done it. So probability X is greater than 15 given that it's greater than or equal to 10. Conditional probability formula will tell you that it's that, so greater than 15 divided by greater than or equal to 10. So what I could do is do it on the, obviously I'm going to do it in the calculator, but I could just re-edit this line, drag it down, change that to 16, not 15, because it's greater than 15, and then we're going to be doing that divided by that. Don't round off the answers until the end. Okay, let's put that in decimal, and we should get 0.086, and we do. So this time 3 decimal places. Make sure you read this carefully. They tend to play around with a number of decimal places, try to trip you up. So moving on. Part B, now we're talking about Paula. She's a member of the gym. She completes S every month, and she finds that her fitness varies. So if she's fit 1 month, probably she's fit the next is 3 on 4. If she's not fit, the probability she is the next month is 1 on 2. Sounds very Markov-y. We don't really need to use Markov chains for this one though. So if she's not fit in 1 particular month, what's the probability that she is fit in exactly 2 of the next 3? So I don't really like the way I've set this out. I probably just could have used a tree diagram, but basically there's 3 possibilities here. So when she's not fit the first month, so then she could be fit, fit, and then not fit, or fit, not fit, fit, or not fit, fit, fit. And the probability of each of those things happening is here. So if she's not fit the first month, then there's a 1 in 2 probability that she will be. So then the probability changes to 3/4, and then 1/4 that she's not the next month. So if you're really confused by these, I would draw out a tree diagram, and it'll make a bit more sense hopefully. Or leave a comment. So it simplifies to 11 on 32. I won't bother putting in the calculator, you can take my word for it. So moving on, fully fit surveyed its gyms throughout the world. So now we've got a probability density function. They're trying to cover all the probability topics in the one question, it looks like. So g of x is my PDF function, and this is the time taken for members to complete S. So what's the expected value of x? Use the formula. Now because I've got 2 bits to the function here, I'll just do them separately. So the answer will be the integral from 1 to 3 and of x multiplied by, I don't think I will actually type all of this in. You can take my word for it that it works. So if you type this in, do your dx and then plus and do another one, you should get 3.0458. Okay, so we'll move on. I will do the next one. In a random sample of 200 fully fit members, how many would it be expected to take more than 4 minutes? So more than 4 minutes, all we really need is the bottom one here. So integrate area under the curve between 4 and the upper terminal will be 5, and we are looking at x plus 29 over 128. And of course this is going to give me the probability that a random person that I choose will be between 4 and 5 minutes. So if there's 200 people, then I'd expect 200 multiplied by 0.26 of them to have taken more than 4 minutes, and we want to round that to the nearest member, which is 52. So put your answer there and then we'll round it off to 52. Okay, so the next question, and it's Tasmania Jones time. I've cleared the calculator, let's do this. So in 2013, Tasmania Jones was in Switzerland working as a construction engineer. So here's our train ride through the mountains, and the cubic that is being drawn here is representing the mountain and a lake bed. So the cross section of the mountain is given by that rule there, and we're told that 0, 1/2 is the highest point on the mountain, and we've been told the x-intercepts, which is the edge of the lake. So we want to start off by finding G, which is the deepest point of the lake. So what I'm going to do, I'm going to define the function this time. So go into Math 3, define, and we'll call it f, use the f button there, f of x, and that's going to be equal to our function. So if when you were in reading time, what you should have done was had a good look at this question, and that's probably a good time to think about whether or not you're going to define the function when you get up to it. So if you need to use it, 3 or 4 times, it's a good idea to have it defined in the calculator. Just when you do this, make sure that you type it in properly. You don't miss off a number anywhere. Otherwise all your answers are going to be wrong. So this is actually my 3rd crack at doing this, because each time I wasn't watching properly and I missed something. So don't do that. Anyway, so f of x is in the calculator now. So if I want to find the deepest point on the lake, I could do an f min. So we'll go into action, calculation, we'll do an f min, and all we need to do is type in f of x or drag that down, and we want to find the minimum. And of course that's given me the absolute min, so I'll put some parameters on it. Given that x is somewhere between 2 and 4. And that should give me the right answer, which is negative 50 on 243 is the minimum value when x is equal to 28.9. So a couple of things to be careful of here. First of all, with your working, you can't just write f min or something like that. You need to do a bit more working. So I've actually written that to find the deepest point in the lake, I'd need to differentiate the function, set it equal to 0, and find x between 2 and 4, and then sub 28 on 9 in. So I've written that that's how you do it, but I haven't actually done any of that. I've just used f min on the calculator to save me some time. The other thing to be careful of is that you do answer the question and actually write the coordinates of G rather than just the x coordinate. Okay, so moving on, the ride is made by constructing a straight railway from AB, from the top of the mountain to the edge of the lake. So the railway goes from here to here, and this section A to D is a tunnel through the mountain. So now what? Write down the gradient of the line that passes through A and B. That's pretty simple. The gradient of the line is just going to be rise over run, so a half over -4, very easy. Surely most people got that right, 81%. Sorry, we're finding the equation of the line. So the gradient's -1 on 8, and the y-intercept is a half, so easy, y equals -1 on 8x plus a half. So you could just use y equals mx plus c there. Okay, moving on, show that the x-coordinate of D, the end point of the tunnel, is 2 on 3. Okay, so how we could do this one is we are finding this point here. So I think the easiest way would be to set the function and the equation of the line equal to each other. And that's what I've written here. So I'm writing that I'm letting f of x equal -1 on 8x plus 1 on 2. So I'm setting the two things equal to each other without actually writing out f of x. I've just written f of x. Okay, so because it's a show that, we're going to show a little bit of working. So we did end up having to write out f of x anyway. If you take everything to the left-hand side, if we multiply through by 8 and then factorize. Now, of course, at any point, your calculator could have done some of that stuff for you. So maybe even once we got to here, we could have factorized it in the calculator or what have you. But the 3 points of intersection is 0, 4, 2 on 3, and of course the one we want is 2 on 3. Okay, so find the length of the tunnel AD. Again, we know the point D, or we know the point A is 0 or half, and the point D, the x-coordinate is 2 on 3, and we can find the y-coordinate easily enough by subbing in 2 on 3 into either f of x or negative 1 on 8x plus a half, so I won't bother doing that. You get 5 on 12, so the distance between 2 points formula will give you this, and that simplifies to root 65 on 12. Okay. Use a calculator, obviously, but I can't be bothered typing that in. Let's move on. Okay, so now we get a little bit trickier. So in order to ensure that the railway line is stable, we have to insert some vertical columns from the lake bed to the railway line. So what we have got up here is this is one of those vertical columns. So there's going to be vertical columns all the way along here. So we want to find where is the point where the longest column would be, I believe. Okay, so what we'll do first of all is we'll define this function where Lx is that column length. Now, of course, the column length is going to be the difference between, sorry to scroll up again, but the column length is going to be the difference between the y value here and the y value here. So the y value there is going to be negative 1 on 8x plus a half, and the y value here is going to be 3x cubed on 64, blah, blah, blah. So I can get an expression for L by doing just that. So L of x, I've called it L, is negative 1 on 8x plus a half minus f of x. So then to get the minimum, we would need to differentiate that and set it equal to 0. Okay, so I'll use the calculator now. So we could have negative 1 on 8x. So this is where defining the function is going to come in handy, because I can just write this minus f of x. So that's my function L of x. And what I could do is either differentiate that and set it equal to 0, or maybe we can use this f min again, or actually it'll be f max, won't it? Oops, sorry, I like to do it in action, not in directive. F max. So let's see what it gives us. Whoops. Now, of course, x has got to be between 2 on 3 and 4. So that will help. Okay. That's right. There's my x value there, 2 root 31 on 9 plus 14 on 9. And then I've actually answered the next question as well. So the next question is find the length of the column in meters. So if I sub 2 root 31 on 9 plus 14 on 9 into the function, I get, well, I could actually just change this to decimal. And there we go there. So 0.336, which is 336 meters. Okay. Okay, so I'm going to clear the calculator here, which is a sure sign that I've stuffed up. So let's have another go at this. So the train is now traveling down the line from A to B, and the speed of that train is given by the function here. So we've got a couple of parameters in our, couple of extra paranumerals in our function, which is annoying. So we're told that the train starts at 0, 1/2, and then when it gets to 4, 0, the speed's 0. So v of 4 is 0. So if you just sub that in, this question's pretty easy. So to find k in terms of m, sub in 0 for v and sub in 4 for x and solve, you get k equals 8m. Okay, so it starts out fairly straightforward. Now we want to find the value of x for which the speed is a maximum. So now I'm going to type this in, 8 times m times the square root of x, and we're going to subtract m times x squared, and we are going to find where this is a maximum. Now we could try using the f min and f max. I don't think it's going to work for this though. because of the m's in there. So, but try it, see how you go. This is a good opportunity to show you how to do it the other way. So if we differentiate and then we set it equal to 0 and solve, which doesn't really take very much longer. And we do have to show similar working in the calculator, so it's not a bad way to do it. We end up with x equals 4 to the 1/3. Working should look something like that. Okay, so now we're told that on a particular day m is equal to 10. So now find the maximum speed of the train. So my m, my function is up here still. So we might just type that in again and sub in that m. It's not difficult to do this by hand, by the way, but let's just make sure we're right. So what happens if m is equal to 10 and the function looks like this? And now let's find the maximum speed. And actually f max should work now. So let's see. There we go. So we're told to have this to 1 decimal place. So the maximum speed is going to be 75.595, which is 6. Of course, I didn't really have to do f max because I'm told that the maximum is when x is equal to 4 to the power of 1/3. So I could have actually just subbed in 4 to the 1/3 into here, and that would have given me the same thing. So, 2 ways to do this question. You could argue that one is a little bit quicker. What I'm doing right now is probably a little bit quicker. And that'll give me the same thing. Okay, so moving on. On another day, the maximum value of v is 120, so find the value of m. So kind of the reverse question here. So this time we're told that using this function here, we're told that the maximum is 120. So that means that if I sub in 4 to the 1/3 in for x, like I did in the previous question, so if I sub that in, the whole thing should be equal to 120. So, whoops. Let's do that. So 6 times 2 to the 1/3 has to be equal to 120. So we're solving that for m. Alright. Probably a little bit trickier, that question. You can see we've dropped down to 25% that got this right. It's going to drop even lower by the time we get to the end of the paper. You'll see that soon enough. So there's the answer, 20 on 2 to the 1/3. If you don't like the look of that, you could see if the calculator, whoops, I want to get rid of that. See if the calculator will simplify it for you. So here's yet another function on the calculator that might be useful. Action, transformation, simplify. Just see if the calculator will make it look a little bit nicer for you. And it has, so 10 times 4 to the 1/3, and there's your answer. One more question to go. Okay, final question, and it gets pretty tricky. So let's have a look. We've got a function g of x is 16 minus x squared on 4. B and C are the intercepts, and we have a tangent drawn here at the point A, and we're told that this tangent is parallel to this line BC, which is going to be useful information. So the first question, find the equation of that tangent. So we're told that, well, we can work out that B is the 0.40 and C is the 0.04 easily enough, and by letting x equal 0 and y equal 0, or however you want to do it. And therefore, the gradient of a line between B and C would be -1. Okay, so at that point, I think it's time to define the function. Whether or not you have to define it is really up to you here. I think I would for this question. We're going to use it a fair bit. So g of x equals 16 minus x squared on 4. There we go, defined, and we want to find where is the gradient of the function. So we know that if the gradient of that line there is -1, then the gradient of the tangent is -1, which means the gradient at the point A is -1. So let's work out where the point A actually is. So to do that, we can differentiate g of x. So I don't need to type it in again. I can just write diff g of x. And we want to, very easy one to differentiate, by the way. We want to set that equal to -1, which you should really be able to solve in your head. But you're going to get that the x coordinate of A is 2, and the y coordinate you can then work out is, sorry, I'm all over the place, I'm trying to talk and look at the same time. So the x coordinate is 2 and the y coordinate is 3. So A is the 0.23. So if you know that A is the 0.23, we can work out the tangent very easily, because, well, you just can. So y minus y1 equals mx minus x1, or however you want to do it. The tangent is negative x plus 5. Actually, if you want to use the tangent, may as well show you this. So we want to find the tangent to the graph of g of x, and we want to find it at the point 2. So we could just do that, negative x plus 5. Alright, so moving on, the shaded region is bounded by the graph of g, the tangent, and the x and y axis. So find the area of the shaded region. That's going to be the area underneath the straight line minus the area under the parabola. So you can do it, you could just find the area of that triangle using half base times height, or set up your two integrals. So I'm actually not going to bother doing this, but you can type that in and then minus and do the same thing, and in here you can actually just put g of x. You don't have to type in what the function is. Alright, you can take my word for it, that'll work, and that'll give you 11 on 6. Okay, moving on, so we're really dropping off now to 15%. It's going to get even lower. Let q be a point on the graph y equals g of x. So let the positive value of the x coordinate of g for which the distance OQ is a minimum. Okay, so we've got some point g on the curve here, and we want to find where the distance from the origin, so the distance from the origin to the point on the curve, where is that distance going to be a minimum? So we just set up an equation for the distance, set up a formula for the distance, which you could just use Pythagoras really. So that that distance squared is going to be that distance squared plus that distance squared. So that distance there is the y coordinate, or x, what is it? 16 minus x squared on 4. And the x coordinate is going to be x. So the function for the distance is going to be the square root of x squared plus g of x squared. Okay, so we can type that into here and see what happens. I might just put an extra bracket around here just to make sure. So that squared, and that is my distance, that is my d of x. Now I want to find where that's a minimum. So again, we can have a try at using fmin. See what we get, where x is between 0 and 4. And that should answer the rest of the question for me, which x is 2 root 2 and the distance is 2 root 3, and that gives it all to me there. Again, make sure you've got some proper working. Nice idea to answer the question again down at the bottom to make sure you've covered all your bases. Okay, so moving on, almost there. the tangent to the graph of G at a point P has a negative gradient, obviously, and intersects the y-axis at 0k, where k is between 5 and 8. Okay, so we want to find the gradient of the tangent in terms of k. So what we can do here, and the examiner's report suggested you do the same thing, is just let this point P, let it be P, 16 minus P squared on 4. So instead of X, so we're just calling it the point P, which gives you, that is your made up coordinates for capital P. So we already know that the derivative of G is negative X on 2. So at the point P, the derivative is negative P on 2. Okay, so what we're going to do is we're going to set that gradient equal to the gradient of the tangent using rise of a run. So using rise of a run, your y2 is k and your y1 is 16 minus p squared on 4. Your x2 is 0 and your x1 is p, or something like that. So what you do is you can set these two things, this whole messy thing, equal to each other and solve for p. So again, you can take my word for it. You type that into the calculator and solve for p. You actually get two options. You get 2 root k minus 4 or negative 2 root k minus 4. We'll cross that one out because p has to be more than 0. So if p is equal to 2 root k minus 4, and the gradient is negative p on 2, we'll sub this in for p, and we have the gradient in terms of k, which is negative root k minus 4. Alright, leave a comment if you're not quite sure what I did there. I'm happy to explain it for you, to you again. Alright, I think there's just a couple more questions now. Alright, find the rule for the function of k that gives the area of the shaded region. Okay, so this is tricky. So because we're trying to find this area, and we don't know the equation of this straight line, we need to do some things in terms of k. So first thing we're going to do is we're going to work out what this x coordinate is here in terms of k. So if, where are we? Here we are. So the equation of the tangent is actually that, because the gradient is negative root k minus 4 and the y-intercept is k, so I can just say the equation of the tangent is y equals negative root k minus 4x plus k. To find the x-intercept, let y equal 0 and solve for k. You get k on root k minus 4. Do that in your calculator. Solve this for k in your calculator. I'm going to save a bit of time and not type that in. But you get k on root k minus 4. So that means that the area of the big triangle here is 1/2 multiplied by k, which is the height, multiplied by k on root k minus 4, which gives you this part here, and then subtract the area underneath the parabola, which gives you this here as your area function. Now I'm going to define that because we need it for the next couple of questions. So I'll type this in here. So 1 on 2 multiplied by, now should I use k's? I might actually use x's here instead of k's. So x on root x minus 4. So just remember when you're writing it on your sheet that you should be writing k's and not x's. I think it'd be an easy thing to do. Okay, and 0 to 4 of g of x, which is still defined from before. So that's handy. I don't have to go back up my screen looking for that. Invalid name. Why is that an invalid name? That's because I wrote define and I just started typing. I didn't actually call it anything. That was stupid. So let's call it, I don't know, let's call it A for area. So A of x equals and then we type in our function. Okay, so you see what happened there. Because I used a as a variable, it didn't like it. You've actually got to use a in ABC. So there you go. So I've defined a of x as my big, scary, area-looking function. And if I wanted to simplify it, which I've done down here, I could just type in a of x again, and it'll tell me that it's this x squared on 2 root x minus 4. Remember, writing k instead of x, minus 32 on 3. Okay, so you can finish off the question now. You can see we're down to 3% and then 2% for the very last question. So find the maximum area of the shaded region and the value of k for which this occurs. Okay, so common sense would tell you if you want to find a maximum, you need to find the turning point. In this case, that wasn't actually true. So if we find the maximum, we actually don't know if it's a maximum or a minimum, do we? Okay, interesting. So what we're going to do here, I'm going to differentiate it. I'm not going to use fmin or fmax. I'm going to diff it. I'm going to set that horrible looking thing equal to 0, and I'm going to solve. And what I'll get is 16 on 3. So we have a turning point, we have a stationary point when x is equal to 16 on 3. So if you sub 16 on 3 into the function which we called a, so a of 16 on 3, this is when defining functions is really useful. A of 16 on 3 is that. So there's a temptation with this question to put that as your answer, but that wasn't actually the maximum. The maximum we actually find at one of the endpoints. So before we move on, and there was a bit of a clue here with the minimum, because if you've just found the maximum, where's the minimum going to be? So you're going to need to look at the turning point, the endpoints as well. So we'll go a of 5, and we'll go a of 8. Okay, and these are my 3 points of interest. So I can't tell by looking at that what that is as a decimal. So I'll just make them all decimals. And it looks like that's the minimum and that's the maximum. So the maximum is when a is equal to 8, which is 16 on 3. And then the minimum is at the turning point when k is equal to 16 on 3. So that's how you could go about working that out. And there's some nice working for you to make sure you've covered all your bases. And that's the end of the paper. So I hope that was helpful. I think the aim was to show you a few sort of new things on the calculator and show you how you could go about doing these. So hopefully that helped you. If you've got any more questions, just let me know. And best of luck with the exams.